Welcome to EDU World Space.
We have problem number 35, which is from the chapter optics or geometric optics in the modern physics. Okay, so we have the figures of thin lenses. We have to calculate the location of the image, and uh, okay, we have to calculate the location of the image for the given uh, quantities or given parameter which are being given to us. Okay, so this is the figure of part A. This is the figure of part A, where radii of curvatures are being given. So let us start with the solution. Okay, so we have to find the object's distance. We have to find the image distance, that is s dash. Okay, in each case we have to find the distance of the image or location of the image. Okay, so let us start. We have relation 1 by s plus 1 by s dash equal to 1 by f, where s is the object distance and this s dash is the image distance. Okay, so we have been provided with the object distance, which is 18 centimeters. So let us write s equal to 18 centimeters, and from this figure we can see that this lens is the converging lens. Okay, yes, so we have to find 1 by f, that we have to find focal length first to get the value of s dash. Okay, so to calculate the focal length we have to use lens maker's formula, which is let us suppose this to be equation number 1. Lens maker's formula is 1 by f equal to n minus 1 by r1 minus 1 by r2. This is known as the lens maker's formula, where n is the refractive index, which is okay. The refractive index is being given as 1.50. Let us write 1.50, and s already being given 18 centimeter. We will be using plus or minus depending on the lenses. Okay, and here r1 is the first curvature and r2 is the second curvature. So now we have to plug in the values. Yeah, so we can see that first curvature is 10 centimeter. This is known as first curvature. This is known as second curvature. Second curvature is 15 centimeter. We have everything. So let us calculate 1 by f equal to 1.50 minus 1 into 1 by 10 minus 1 by 15. And one more thing to be noted, that R2 here must be negative, as the object we will be taking in on the left side. So R2 must be negative. So let us write minus 15 over here. So this is 0.50, 1 by 10 plus 1 by 15. So this will be 0.50 into this will be 30. 3 plus 2, 1 by 6, that is 1 by 12 centimeter. So f will be 12 centimeter. This is, of course, it should be plus 12 centimeter. Now let us plug in equation number 1. 1 by s, s is 18 centimeter, then 1 by s and plus 1 by s dash. 1 by s dash equal to 1 by f, that is 1 by 12. So 1 by s dash will be 1 by 12 minus 1 by 18. So this is LCM of 12 and 18 will be equal to 36. 3 minus 2, 1 by 36. So s dash, that is required object distance, will be equal to plus 36 centimeters. So this is the answer for part A. Now we'll be answering for part B. Okay, so this is the figure for part B, we see that right side of the figure is flat. Okay, so now we will be using again Lensmaker's formula to get the value of focal length, that is 1 by f equal to 1.50 minus 1 into 1 by r1. R1 is 10 centimeter minus 1 by, here since this is flat, so flat, any flat surface will have radius for curvature infinity 0.50, 1 by 10 minus 0, because 1 by infinity is anyhow 0, so this will be 0.50 by 10, which means 100, so 1 by 20,000. Okay, so f equal to 1 by f equal to 1 by 20 centimeter. So this is value of focal length. Now we will be just plugging in the values in our equation number 1, which is 1 by s plus 1 by s dash, 1 by s dash equal to 1 by f, which means we will be having 1 by f, that is 1 by f is 1 by 20, so let us write 1 by 20, and uh, we have 1 by s, that is s object distance, which is 18 centimeter, plus 1 by s dash. Okay, so from here 1 by s dash will be equal to 1 by 20 minus 1 by 18. Okay, so we will be having this LCM equal to 180. Yes, so 9 minus 5, 4 by 180, that is 1 by 45. Okay, wait, I think there is something missing over here. Yes, there was a mistake, that this should have been 10. Okay, because 18 tens are 18, 10 times is 180, so minus 1 by 180. Okay, so s dash, that is image distance, will be minus 180 centimeter. Okay, negative sign means the image is formed to the left of this lens. Okay, this is the answer for part B. For part C, let us start with the figure. So this is the figure for part C. Okay, so we can see that this is the diverging lens. Okay, so now we will be proceeding further. So we can easily see that R1 is 10 centimeter, R2 is 15 centimeter. Okay, now we will be using Lensmaker's formula, 1 by f equal to n minus 1, 1 by R1 minus 1 by R2. Okay, so we can easily see that uh, since this is converging, diverging lens, so it will be minus n minus 1, 1 by R1 by 1 by R2. So let us plug in the values. The minus 1.50 minus 1, 1 by R1 is 10, and 1 by 15, so this will be minus 0.50. This is 15, LCM will be 30. Okay, LCM is 30, 3 minus 2, so this will be minus 0.50 divided by 30. Okay, is this good? 0.50, 30, 3, 2. Okay, and one more thing I have missed, that R1 will be, if R1 will be positive, R2 has to be negative. So this, okay, into 5, 6, So we have 1 by f equal to minus 1 by 12 centimeter. Now we will be plugging in the formula 1 by s equal plus 1 by s dash equal to 1 by f. Okay, so 1 by s dash will be equal to 1 by f minus 1 by s. Okay, so 1 by f is minus 1 by 12 centimeter, and 1 by s will be equal to simply 18. Okay, so let us calculate. Let us take minus as common. It will be LCM 36, 3 plus 2, which means this is minus 5 by 36. So minus 1 by 7.20. So s dash, that is distance of the image, will be minus 7.20. So image is to the left because this is negative. Okay, now comes part D. Okay, now in part D we have R1 10 centimeter and R2 we have 15 centimeter. It is a combination of, okay, okay, no problem. We can write this is the combination of two uh, what we say converging lenses. Okay, or we can say one converge, one diverge. No problem. So let us start with 1 by f. Formula 1 by f equal to n minus 1 1 by r1 minus 1 by r2, where r1, this is r1, this is r2. So we will be taking both negative, as this is towards the left, this will be towards the left. So in this case 1 by f will be equal to 1.50 minus 1 into 1 by r1, that is minus 10, and minus 1 by r2, that is minus 15 centimeters. So this will be 0.50 minus 1 by 10 plus 1 by 15. So 0.50, this is 30, this is minus 3 plus 2. So this has to be equal to 0.50 into minus 1 divided by 30. So after calculating, we will be getting the value of 1 by f equal to minus 1 by 60 centimeters. Okay, now we will be plugging in the formula 1 by s plus 1 by s dash equal to 1 by f, and from here we will be getting 1 by s dash equal to 1 by f minus 1 by s. So 1 by f means minus 1 by 60 and minus 1 by 18. Okay, so we will be having the LCM of, no problem, let us write only 60 into 18, which means it will be minus 18, it will be minus 60, so minus 78 by 60 into 18. Okay, which means 1 by s dash equal to minus 78 by 60 into 18. So s dash will be with negative sign 60 into 18 by 78. Let us use calculator. 60 into 18 divided by 78, that is 13.85 with negative sign. So in this case, image distance is minus 13.85 centimeters. Thank you. These are the answers. Thank you so much.